Today's lesson is 7-3. Now, before we get started, I wanted to... before we get started, I want to talk about the three forms of a linear equation because we're getting into linear equations. And I'm going to be talking about them quite a bit. And I will refer to them by name. So the first one, the one that we're most familiar with of linear equations is called slope-intercept. So this is when we have slope-intercept. Okay, so the first one is slope-intercept. So the slope-intercept, and here's how it looks. Y equals mx plus b. This is where we have y alone. Okay, the second form of a line is called standard form. And standard form of a line looks like this. AX plus BX, notice I'm using capitals, plus BY equals C, where A, B, and C are integers. Okay, integers. Integers. Okay, notice A, B, and C are numbers, are whole numbers, positive or negative. Okay. The last form of a line is called... point slope. And that is where we have y minus y1 is equal to m times the quantity of x minus x1. Now we are days away from this, but we will be doing this. I'm not really even going to talk about point slope today. I'm not going to talk about it today. But these slope-intercept and standard form, you should have seen already. So when I have the equation, I want you to tell me is y equals 3x plus 2. What form of a line is that? It's the slope-intercept. So that would be y equals 3x plus 2. What about 3x plus y equals 2? David? Standard form. That's standard form. Notice that it is... I've got like 3x plus 2... plus y equals 2. That's standard form of a line. Okay, next we have point slope. Well, let's just forget about this. It's going to look like this. Y minus 2 equals 2/3 times x minus 1. But don't worry about that because you're not ready for it. We got a lot more learning to do. Okay. The ones I want you to be familiar with are your standard form and your slope-intercept. got to know these. Right now, today. All right, can I erase? Oh, is everybody done? Okay, so now I'm going to move on to the PowerPoint. Let's start with just graphing a line. A little bit of something that you did last night. Okay, let's take one that's a little bit more difficult than this. Well, actually, I'll do this one, and let's just look at it. We'll do the next one. We'll take a little bit more time. So in the equation, y equals 2x plus 1, what would be the first thing that I do? Sarkis.
Find x, come up with, multiply, well, do 0, negative 1, 0, and then 1, and then multiply.
I don't do, who can clarify what he's saying? David.
Choose 3 numbers for x.
Choose 3 numbers for x, okay, and substitute x in, substitute those numbers in. Yes.
Like, can I say 3 numbers?
Sure.
You would want to pick negative 1, 0, and 1.
Negative 1, 0, and 1. Keep it close to 0. And so we're going to do that. Of course, my PowerPoint's picking more. But what I say, what I say is all you need is 3 points to graph a line. Okay, so I choose negative 2. I substitute that in for x. And I find that negative 2 times 2 is negative 4 plus 1 makes negative 3. When I choose negative 1, we end up with negative 1. When I choose 0, I get positive 1. When I choose 1, I get 3, sorry. When I choose 2, I get 5. And when I choose 3, I get 7. I can keep going. I can pick an unlimited amount. I can even pick a fraction. Okay? Yes, Piper.
So when you're doing those numbers, you don't have to show all the work where you go down and go like 4 plus 1, and then like...
Just make sure it's right because a lot of students lose information. Okay? So, you know what? As the equations get more complicated, I think you should show the work. I'm just worried you're going to lose a negative in there. And that's going to make, if you know that this is a linear equation and you end up with a line that looks like this, here's the thing. Your line is off. This chapter's linear equations. And I'm going to talk to you about how to identify linear equations. So then I plot my points. Negative 2, negative 3. Negative 1, negative 1. 0, positive 1. 1, comma 3. 2, comma 5. 3, comma 7. 4, comma 9. Okay, questions there? Now, can I do a fraction? Could I have done a fraction? When x is 1/2, what does y become? Ben?
2.
2. My 2's cross cancel. And then what I'm left with is 1 plus 1, that makes 2. So yes, and when I plot it, it's when x is 1/2. I go in here and then come up 1, 2. Is that on the line? That's on the line. 1/2, comma 2. I can graph that. What I don't like about fractions is you really have to estimate and eyeball it. Math is very accurate. It's very black and white. There's no, well, it's kind of this answer. In science, when you use math, it's your tool. It's your number one tool to design rockets, to design the height of something. If something goes too high up, it may land in the wrong place. If you're blasting, let's say a space shuttle, you have to be in position to land in the right place. So it's extremely accurate. There's no kind ofs. And eyeballing something doesn't really go in math. But can you do it? Sometimes you might have to. But I'd say don't choose. Don't try and pick fractional amounts. Okay? All right, so this is the equation for y equals 2x plus 1. And sometimes when I do this, if I have two equations, when we start doing systems, I will put y equals 2x plus 1 to describe that line. That means any number you substitute in here, it's a pattern, and you will get something out here. And this line doesn't stop here. It goes on and on and on and on forever in both directions. And that's why we have our arrows on the end. Does that make sense? All right, so now I'm going to move on. All right, linear versus nonlinear. A linear equation has x to the first power, and also x and y are generally on different sides. They can't be multiplied together, or they just can't be multiplied together, or they can't be, it has to be x has to be to the first power. So, y equals 3x. That's a linear equation because x is to the first power. Please write these down. And then we've got y equals 3x squared. Why is this not a linear equation? Why is this not a linear equation? Yes?
It's the second power?
It's to the second power. Anything to the second power, when you graph it, it's going to have to account for the negative value. So let's say, my result is -1 and +1. And you're going to get something that looks like this. That's completely second semester. It's called a parabola. Parabola. Okay? So anything x squared will give you a parabola. Y equals x over 2 minus 1. What power is x2? First power, so it's linear. Why is this one not linear? David?
Because it's a fourth power. I have a question.
Yes.
If it's to the second power and it's a parabola, then if there were to be
It looks like this. It looks like third power is like that. And we're going to just stop for fourth power and keep moving on with our lesson. Okay? We're not going to talk about what we're not learning right now, because this is a really long lesson. Okay, so this one again, x is to the first power. X and y are separate. Y equals the square root of x. This is basically the opposite of a square. So it's not linear. Circumference is linear, because in linear equations you have a constant. Here's the constant. This constant is y equals 1/2 x minus 1. The constant is here. Here's my constant. It's what we call a slope. It's always going to be the same. But it's always going to be the same. If you use pi in the circumference, it's always the same amount. Okay? So our linear equation really looks like this. Y, do you remember linear equations from last year? Y equals mx. So pi is like your slope. Okay? I just don't have the plus b. The plus b is 0 in that equation, in circumference. So circumference is linear, but area, think of area of a circle. Is that linear or nonlinear? Because you have r squared. That's like your x. Does that make sense? Perimeter is linear. But again, area of any kind is going to be, because feet times feet is feet squared. So area is not linear. X plus y equals 7. That's linear because we can get the x on the other side. We can manipulate that. We can subtract x, and then I get negative x plus 7. But x times y equals 7, not linear. I can't have them multiplied together. So this is linear versus nonlinear. Now, does everybody pretty much get the table method, or are people still struggling with it? Who's having a hard time with doing the table method? Okay, because I'm going to go on to one more method today. But first I'm going to review this one more time. So what form of a line is that? Somebody else? David's answered all the questions. Sarkis has answered questions. How about Rogelio?
That's standard form.
Standard form of a line. Okay, so what would I need to do to get the y alone? Because it'll be easier in table to make a table. Luke? Subtract 3x from both sides. And I'm left with 2y equals negative 3x minus 4. Nicole, what would I do next?
Next you have to divide 2 on both sides of the equation.
On both sides or all terms? So that means 2 is divided, negative 3x divided by 2, and 4 is divided by 2. Negative 4 is divided by 2. Now I'm going to keep the improper in front of the x. But 4 divided by 2 is what? 2. And that's much easier to work with in an equation. So that's the equation I'm going to substitute in. Now, why did I pick 6, negative 4, 2, 0, and 2? I haven't seen any girls raising their hands. Thank you. Except for Nicole. Sarah.
Because they're all multiples of the denominator 2.
Right. When you have a fraction for your slope, in the number in front of the x, I want you to pick multiples of the denominator. And this is what's going to happen. If I do that, 6 is a multiple of 2. Now what I can do is cross-cancel my denominator. I'm left with negative 3, and negative 3 times negative 3 is minus 2 is 7. And so there's my y. The ordered pair is negative 6, 7. Negative 3 over 2 times negative 4. Sometimes my kids like to put it over 1 to keep it lined up. Minus 2. 2 goes into 2 once and into 4 2 times. So negative 3 times negative 2 is positive 6 minus 2 is 4. Do you see how many negatives we can lose if we don't show that work? Negative 3 over, I'm going to switch colors. It's getting crazy. Negative 3 over 2. This time I'm multiplying by negative 2 over 1 minus 2 is equal to positive 3 minus 2, which is 1. This is always easy. I love doing 0. Oops. 0 is good because Yeah, it cancels everything out. So it just ends up equaling negative 2. And negative 3 over 2 times 2 minus 2 makes negative 5. So now I've got my points. William.
I'm kind of confused about this.
Okay, what part?
The changing it into a function and the like plugging it into the table.
Okay, so you're confused of how you get the y alone?
Yeah.
Okay, good question. So can I erase this? I'll come back to it. I have it on the PowerPoint. So let's go back first. So the very first beginning was function form is getting y alone. So what do I need to do to get my y alone? What would you do?
You have to subtract 3x from those sides.
Good. And then you're left with 2y equals negative 3x minus 4. So now what am I doing? Is my y alone?
Well, we have to divide by 2.
So I'm dividing all parts by 2. That means I'm not only dividing, I divide all terms. This term, and this term. When I put it under everything, it means under everything. Each one in particular. So this really means 2y over 2 equals negative 3x over 2 minus 4 over 2. Now the first one simplifies to what? William. Y. The second one simplifies to what? Well, it just keeps, it's just 3 halves and I bring the x to the middle. And the third term, good. So that's the equation I'm putting in here to get my y. Now, the next part. What numbers? We choose our numbers. Why did I choose these? 6, 4, 2. They're divisible by 2. So I'm going to, is the first part right here clear to you? And what they mean by function form is just get it in the, right now, just let's take that as, get it in the form of a y. Get y by itself. Okay? Now, I'm choosing those numbers so that I can do some cross-canceling. Because this is the same thing as negative 6 over 1. Do you understand the cross-canceling part? What can I divide? Let me rewrite it so it's a little bit clearer. So if I'm doing, now I can go here. Okay, so I'm substituting in. All I'm using is this part of the equation because I'm going to put my equals y over here. You with me? So I'm doing negative 3 over 2. When it's next to x, that means times x. But this time for x, I'm going to call it negative 6 over 1. Doesn't that equal negative 6? Okay. Then minus 2. Now, I think about what number divides into 2 and 6. What common number divides 2? 2 divides into 2 one time. 2 divides into negative 6 negative 3 times. Do you understand that?
Yes.
So now what I'm left with is negative 3 times negative 3 is what?
Negative 9. Oh, no, positive 9.
Positive 9 minus 2. Positive 9 minus 2 is? Perfect. Let's try another one. Negative 3 over 2 times what, William?
4 over 1.
Negative 4 over 1 minus 2. What can I cross cancel, William? I can take out 2 here, I'm left with a 1. And I can take out 2 here, and I'm left with negative 2. What does this become? Negative 3 times negative 2
Is negative, no, positive 6.
minus 2.
Negative 4.
Okay, do you understand it now?
Yes.
Okay, so now I take those and I need to graph them. Negative 6, comma 7. I start at the origin. I count back. The first x term goes on my x-axis. Start at the origin, the center. And I count back 1, 2, 3, 4, 5, 6 this way to the left. And then I go up 7. Plot the point. Negative 4, positive 4. Negative 2, left 2, up 1. 0 across, 2 down. Negative 2. 2 positive to the right, 5 down. Negative 5. And then I make a line. Now, notice what I'm doing. Notice that my graph is not a baby line. I don't have this isn't my line. That's what I call baby line. Do you see that? I never want to see baby lines. I want you to continue, even if your 3 points are within here, I want you to continue it all the way. Okay? And put arrows, because this line is the pattern for all points forever and ever and ever in this direction. In addition, I'm going to give you 0 points if you're not listening, and I already see people not looking and listening. So I want arrows at the end of the line. You don't have to go up here in space. I want your X and Y axes labeled and also arrows on them. X and Y axis, I want them labeled. And I want my arrows on the ends, because this means these lines go on forever. So no baby lines, label all parts. Now, once I'm done, if you want to, you can say this is y equals negative 3 over 2, x minus 2. Or you could use the original, remember the original equation was in standard form? You could use that as well. When we get to systems, so you could have done 3x plus 2y equals negative 4 on that line too. When we get to systems of equations, it's 2 equations per graph. The one more thing. Notice the table, the graph are right next to each other. All the work is next to each other. Don't do all your tables on one page and all graphs on another. And how many lines per graph?
3. 4.
There's 4 lines that you can graph on this. There's 1 line per graph. I only want you to graph 1 problem per graph. Okay, 1 linear equation per graph.
I didn't know that's what you meant.
Okay. All right. We're going to skip this and move on to X and Y intercepts, a new way to graph. So I've showed you how to graph using tables. Now I'm going to show you how to graph using intercepts. Sarkis.
Are we going to have to make a lot of little graphs?
Yes.
Okay.
It's a high school course, so if that's a problem for you. Okay, good. Do you see the 2 little blue dots that I put on? Those are what we call, oblique just means it's diagonal as opposed to vertical or horizontal. The 2 points I put on the X and Y axis are where the line, the linear equation, meets the X and Y axis. This point, what is the ordered pair? The top point in blue, what is the point? Oscar.
5.
That's not a point. I need an ordered pair.
0, 0, 5.
0 across, comma 5. Okay, and we call that, what axis is it? It is the y-axis, so it's the y-intercept. Y-intercept. The next one right here, what's the ordered pair? Luke? And that is on what axis? The x-axis, so that is which intercept? That is where the linear equation meets the x-axis is called the x-intercept. We're going to learn to graph using x and y intercepts. Okay? Can I erase? Yes.
I didn't get a question on homework. It said like
I'm going to go to the homework at the end, hopefully. Okay, I'm moving on. Now, if they say use x and y intercepts, don't worry about that. Oblique just means, okay, yeah, let's use this one. Let's pretend they want us to graph. I'm going to pretend they didn't put this here. They want us to graph using x and y intercepts. The directions say graph using the intercepts. So what I generally like to do is, I know if I go back, the one thing they both have in common is they're both on the x and y axis. And if I look here, wait. Okay, if I look at this one, both x and y intercepts have 0. That's what they will always have in common. They both have a 0 in their ordered pair. Okay? So, when I'm looking for the x, I said I'm gonna, okay? They didn't give us the table. All they're giving us is y equals 2x plus 3, and they're saying graph using intercepts. So that means how many points? 2 points. So the first thing I do is I set myself up a nice little table right here that says x and y. I'm going to set 1 equal to 0 and 1 equal to y. So the first one I'm going to do is where x equals 0. Okay, when x equals 0, I'm going to do y equals 2 times 0 plus 3. What does that y equal?
3.
Okay, so the ordered pair is 0, comma 3. Is that 0 across 1, 2, 0 across 1, 2, 3 up?
No.
Now, what's no? David.
Oh, no, it actually is.
Okay, so my question to you is that the y-intercept or the x-intercept? It's the y-intercept. Okay? So when I set x equal to 0, it's the y-intercept. Notice your answer comes out in the y. Now, for the x-intercept, I'm going to set what equal to 0? And we found that this is 3. Okay, now when I set y equal to 0, 0 equals 2 times x plus 3. What do I do to get the x alone? Ziamara? And then I'm left with negative 3 equals 2x. Next step, Lucy?
Divide by 2 on each side.
Divide by 2. And x equals negative 3 over 2. Okay? So this is going to be my x-intercept. And the ordered pair here, I have no more room, so I'm going to put it up top, is negative 3 over 2, comma 0. What is 3 over 2? Make sense of that number. What is that on the number line? Sarkis.
It's going to be negative 1.5.
1.5, 1.5. So, to do that point, I'm going across 1.5, and then I'm going up 0. I have my 2 points now. I'll make one blue. Does that make sense? Okay, so now, yes.
I'm a little confused. I thought you would probably go down 3 and then left.
Nope.
Isn't it rise over rise?
That's not a rise over run. It is not a slope. It is an x. Make sense of it. This is negative 1.5. Do you understand that? So I'm going across 1.5, and then up 0. Okay, yes, David.
Why didn't you choose negative 3 over 2? Why didn't you?
I didn't choose 3 over 2. I chose to use the intercepts. Okay, negative and then I draw my line. So basically, let me summarize. When you graph or solve using intercepts, you set x equal to 0 and solve for y. You set y equal to 0 and solve for x. And you graph those 2 points on the x and y axis and create your line. Now let me show it to, can I erase this or no?
No.
Who's still using it? Give me a thumbs up.
Are we ever going to check homework?
Can I continue? I got to move on. So look at your neighbor. So, guys. So using x and y, using the x and y intercepts is what I can use to graph a line. You got to learn this method. When it says solve or graph using intercepts, I want you to find the intercepts and graph it that way on those problems. Because this is a district assessment question. Constructed response. So you've got to learn that method. So we have 2 methods. Table method and graph using intercepts. Now, in this one, when you graph using intercepts, you don't have to get y alone. Look up here. So I set, for the x-intercept, I set y equal to 0. Okay, for the y-intercept, I set x equal to 0. And that is, my x-intercept is going to be 3/2, comma 0. My y-intercept is going to be 3, comma 0. Please stop tapping. I don't need your help, thanks. All right, so they'll give this to you in the directions if they want you to do this. Find the x-intercept, find the y-intercept, plot those 2 points, and draw the line. Okay. Now, one more thing, horizontal and vertical lines. When you have an equation like y equals anything, y is, set up a table. So, one more time. Oh, this is not helping. This is what I call a oblique line because it's diagonal. Okay? If I have x equals, you're going to set your table up like this. X and y. That means x is always going to be -2. And I choose the y. Okay, so I'm going to go 0, 1, 2. So then I start at the origin. I go over 2, up 0. Over 2, up 1. Over 2, up 2. What kind of line is this? So anytime you have x equals, it will be a vertical line. Anytime you have an x equals, x will be a vertical line. Yes.
I don't understand the why you just chose the numbers.
Just like normally we choose our x values, in this equation, x is constant. And you choose the y values.
So you could do -1, 1, and
You could anything. It's just gonna be down here. Okay? Now, if y equals 3, this time what am I setting? Rogelio?
So y is going to be all negative.
All threes. All threes. And I choose my x's this time. And it will be the opposite. Horizontal. You need to, excuse me. Okay? All right, so now, any questions? Let me make sure this is the end. This is basically it. All right, so let's say it was a very long PowerPoint. I'm going to say that's the end of the lesson. And please take out your homework very